Have you ever wondered how a bulb works? What's the magic behind that simple flick of a switch that illuminates your room? Welcome to the fascinating world of light bulbs, the unsung heroes that banish darkness and bring light into our lives. It's a world that's as diverse as it is illuminating, with a spectrum of light bulbs that cater to varying needs and tastes. From the humble, incandescent bulb that Thomas Edison made famous, to the energy-efficient compact fluorescent light bulbs and the technologically advanced LED bulbs, each type has its unique characteristics and benefits. So how does a bulb transform electricity into light? It's a fascinating process that involves a blend of science and engineering. Each bulb, irrespective of its type, has a set of common components that work together to produce light. Keep watching to unravel the mystery behind the everyday phenomenon of a light bulb. You might think a bulb is just a bulb, right? But there's more to it than meets the eye. Let's dive into the fascinating world of light bulbs. At first glance, they might all look similar, but there are actually several different types of bulbs. Each one has its own unique features, uses, and benefits. First up, we have the classic incandescent bulb. This is the one most of us are probably familiar with. It's been around for over 100 years and is known for its warm, inviting light. Incandescent bulbs work by passing electricity through a wire filament until it gets so hot that it glows. But they're not the most energy efficient, converting only about 10% of the energy they consume into light. Next is the fluorescent bulb. These bulbs are filled with a gas that emits UV light when excited by electricity. The inside of the bulb is coated with a phosphor material that converts the UV light into visible light. Fluorescent bulbs are more energy efficient than incandescent bulbs, but they can sometimes cast a colder, harsher light. Then we have the LED, or light-emitting diode bulb. These bulbs are the new kids on the block, and they're taking the lighting world by storm. LED bulbs are incredibly energy efficient and long-lasting. They work by passing a current through a semiconductor material, which then emits light. LEDs can produce a variety of light colors from warm to cool, and they don't get hot to the touch like incandescent bulbs. Last but not least, we have halogen bulbs. These work in a similar way to incandescent bulbs, but they're filled with a halogen gas that allows the filament to glow brighter and last longer. Halogen bulbs are often used in car headlights and outdoor lighting because of their bright white light. So there you have it. Whether it's the warm glow of an incandescent, the energy efficiency of a fluorescent, the versatility of an LED, or the brightness of a halogen, there's a bulb out there for every need and preference. Now that you know the different types of bulbs, let's understand how they work. What's inside a bulb? It's not just air and a tiny wire. Indeed, every bulb is a marvel of engineering, a small universe unto itself. It's a fascinating world that's often overlooked. But today we're going to take a deep dive into the heart of this everyday item. At the very core of a bulb, you'll find the filament. This is the heart and soul of any light bulb. It's a thin wire, usually made of tungsten, that glows when electricity passes through it. The filament is the very essence of a bulb's functionality. It's like the sun in our mini-universe, providing light and warmth to the surrounding environment. Now, how does this filament stay in place? That's where the base comes in. The base, typically made of metal, holds the filament in place and provides a way for electricity to reach the filament. The base is like the earth in our bulb universe, grounding the filament and keeping it safe. It's the unsung hero of the bulb, often overlooked, but without it, the filament would be lost in space. Finally, we have the glass bulb itself. This is the protective shell that keeps the filament and base safe. It's like the atmosphere in our bulb universe, protecting the filament and base from the harsh elements of the outside world. The bulb is filled with an inert gas, like argon or nitrogen, which prevents the filament from burning out too quickly. The bulb is the final piece of the puzzle, the outer layer that keeps our bulb universe intact. But the bulb isn't just a protective shell, it also plays a crucial role in the light emission process. The shape of the bulb can affect how the light is spread, whether it's a focused beam or a broad glow. Different bulb shapes can create different lighting effects, allowing you to customize your lighting environment to your liking. With these parts in place, a bulb is ready to light up your world. So the next time you flip a switch, take a moment to appreciate the mini-universe inside your bulb, working tirelessly to bring light into your life. The magic of light begins with a simple flick of a switch, but what's happening inside the bulb? Let's start with the classic, the incandescent bulb. It's made up of a thin tungsten filament, a glass mount to support the filament, and a glass envelope filled with inert gas to protect the filament. When you flip the switch, electricity rushes through the filament, a process known as electrical resistance. This resistance generates heat, causing the filament to glow white-hot. This glowing is what we see as light. However, this process isn't very energy efficient. In fact, about 90% of the energy is wasted as heat, with only 10% converted into light. Now, let's consider a more energy-efficient option: the compact fluorescent bulb, or CFL. Here, instead of a filament, we have a tube filled with a bit of mercury and an inert gas. When the electricity is switched on, it excites the mercury atoms which emit ultraviolet light. This invisible ultraviolet light then strikes the phosphor coating on the inside of the tube, causing it to fluoresce or glow, producing visible light. This process is more energy efficient than incandescent bulbs, using about 75% less energy. But the true champion of energy efficiency is the LED, or light-emitting diode. An LED bulb works a bit differently. It's made up of a semiconductor material, impregnated or doped with impurities to create a PN junction. As we apply electricity, electrons are able to recombine with electron holes within the device, releasing energy in the form of photons. This process is called electroluminescence, and the color of the light corresponds to the energy of the photon. LEDs are even more energy efficient than CFLs, using up to 85% less energy than incandescent bulbs. It's worth noting that while these bulbs may seem simple, they are the product of numerous scientific breakthroughs and technological advancements. For instance, finding the right materials for the filament in the incandescent bulb was no easy task. It took years of experimentation before Thomas Edison discovered that a carbonized cotton thread could endure the heat. Similarly, the development of efficient LEDs required a deep understanding of quantum physics and material science. So when you flick that switch and your room is bathed in light, remember that you're not just looking at a simple bulb, you're witnessing a piece of scientific and technological marvel, a testament to human ingenuity and perseverance. So that's the science behind the magical light of a bulb. So are bulbs still just bulbs for you? Or do you now see them as intricate pieces of technology? We've journeyed together through the fascinating world of light bulbs, and hopefully you've gained a new appreciation for these everyday objects that illuminate our lives. To recap, we've learned about the different types of bulbs. We've seen how the humble incandescent bulb with its tungsten filament has given way to more energy-efficient options. Fluorescent bulbs, for example, create light through a chemical reaction, offering longer lifespans and lower energy consumption. And then we have LED bulbs, the new kids on the block, which provide unparalleled energy efficiency and longevity thanks to their innovative design. We've also delved into the inner workings of a bulb. We've discovered that the bulb is more than just the glass part that emits light. It's a complex structure composed of several parts, each with its own crucial role. The filament or LED chip that produces light, the base that connects to the power source, and the envelope that protects these components and helps distribute the light. But what truly brings a bulb to life is the science behind it. We've learned how a bulb works, how electrical energy is transformed into light energy. In incandescent and halogen bulbs, electricity heats a filament to such a high temperature that it glows with visible light. In fluorescent and LED bulbs, electricity excites a gas or a semiconductor, causing it to emit photons or light particles. So you see, a simple flick of a switch sets off a chain of intricate processes, all resulting in that familiar glow that lights up our world. It's a testament to human ingenuity and our ceaseless quest to conquer darkness. Next time when you flick that switch, remember the fascinating science that makes it possible for you to have light at your fingertips.